past year has been difficult. Living through a global pandemic is exhausting, but it does give perspective. Now more than ever, we see the need for fast and effective responses to disease outbreaks. So how do we address that goal? How do we make sure that our response to disease outbreaks are not only timely but efficient? That's the mission set out by my project. Figure It Out is a game designed to increase the use of quantitative research evidence in decision-making by public health workers in developing countries. It's a text-based game with integrated minigames. The users play as public health officials in Liberia attempting to stop a disease outbreak by collecting data, researching possible diseases, and ruling out ineffective treatments. This project is a combination of two teams, a team of data scientists and analysts from the Institute for Disease Modeling, and a team of game design and development students led by a professor from my university. When the other students and I were brought on, we were tasked with creating a prototype of how the game would look and function. While my teammates began working on the main game, I turned my focus towards the mini-game. My specific mini-game was titled Search Savvy. Its goal was to mimic a search engine in order to help users practice crafting searches that will yield specific and relevant results for the outbreak they're trying to solve. The bulk of my work focused on scoring their search. Initially, I stored user input as a string, then parsed that string. However, that quickly became way too rigid for what we needed. My next idea was to create a data structure that contained variables to describe the search term. Was it a symptom, an epidemiological term, a location, or a disease? Was it in quotes? Was there a minus sign before it? These were all important questions, but this way of representing the data grew to be overwhelmingly complex and was still difficult to score. At this point, I reached out to my teammates for advice, and finally I was able to gain traction when my team lead suggested that I work in multidimensional arrays. From there, I programmed a series of functions that recorded the user's input in a 2D array. For each search term added, it would record an integer representing the term's modifier, an integer classifying the type of search as symptom, disease, location, or epidemiological term, and an integer to represent which term it was. This gave us important flexibility in our scoring algorithm, because in some instances, like for example symptoms, the scoring was as simple as is the term relevant and is in quotes, whereas for others, such as epidemiological terms, we had to check which term it was and if the modifier was relevant to that specific term. Once the player hit submit, the array was then scored in 4 categories, one for each type of term. From there, we could give the player specific feedback about where they were doing well in their search and where they still needed to work. Within the prototype, the players encountered the minigame twice. In the first game, we focused on introducing the player to the concept of using modifiers like quotation marks to include terms and the minus symbol to exclude them. We achieved this by guiding the player through feedback on their searches. As you can see in this demo clip, the player has access to just the possible search terms, and there are only 2 types of terms available. We limited it like this to direct the player's attention towards the modifiers, as for many users this will be their first introduction to the concept. When the player submits their search, they are prompted via feedback to redo the search with the relevant symptoms and quotation marks, which are now available for use. After the player completes this goal, they are told that the search contains results they know aren't relevant, and that it can further be refined by using the minus symbol. The player then repeats the process a 3rd time, this time with the minus sign available, and assuming that the player follows all the feedback given in the previous examples, they're given a code to continue in the main game. The second time the player encounters the minigame, they have gathered more information about the disease outbreak, and they're in a better position to research how to treat it. This time, the player is thrown in with the full set of key terms and the modifiers from the start, but they aren't completely on their own. As I mentioned previously, the scoring algorithm evaluates responses for each type of key term. This means we're able to check how many symptoms they included correctly, which epidemiological terms they included or excluded, if they included a location, or if they ruled out any irrelevant diseases. With that information, we can provide specific feedback in order to help the player refine their search and advance towards their goal. So where do we go from here? Figure It Out and its associated minigame is at a phase where we're ready to start testing it with members of its target demographic. As such, we're bringing on board Masters of Public Health students from a university in Liberia. These students will go on to become the frontline workers that prevent and treat real-life disease outbreaks, and with their feedback, we'll be able to refine and iterate our current prototype until it's in a state where we feel comfortable moving into developing the complete app. there's still much more to do, with minigames to create and disease outbreaks to limit. So for now, we're working to figure it out.